Hey guys, welcome to my channel. This is a video that I decided to do based on the problem that I saw on an SAT practice exam. I thought it was very fun and therefore I just wanted to do it. And most people will see this type of problem in Algebra 2. So if you're in Algebra 1, it's still good to solve a problem like this. It just gives you good practice. So let's dive into it. We have a rational expression and we need to simplify that expression. Now, this is actually easier than what you think it might be, but in order to be successful at this, there are some things that we need to remember or recall. Because I have two fractions adding each other, I will need to use this rule for adding fractions that says if I have a fraction a divided by b plus c over d, the way that I add them is I can multiply b times d to find the common denominator, and then multiply whatever I don't have on b to a, whatever I don't have on d to c. In other words, what I have on this denominator that I don't have on this one, I need to multiply it to the one on the top. The numerator. Sorry, I shouldn't have said the one on the top. That is just bad math vocabulary. So let's dive into this. The way that I like to do it is I like to focus on the hard stuff first. So I'm going to focus on this first, and I'm going to write that down here. So if I have 1 over y minus 4 plus 1 over y minus 3, if I'm adding this to rational expressions, well, what I can do is I can multiply my denominators in order to find a common denominator. In this case, y minus 4 times y minus 3 is just y minus 4 times y minus 3. Well, and again, because I don't have a y minus 3 on this denominator, I need to multiply to my numerator here. Well, y minus 3, that's a bad arrow, times y minus 3 times 1 is just y minus 3. And then y minus 4 times 1 is just y minus 4. Remember that the reason that I'm multiplying is because I don't have that y minus 4 on this denominator. Well, right now what I can do is I'm going to combine like terms. So in this case I have y plus y, that is just 2y. Negative 3 plus negative 4 is negative 7. Well, the bottom, it looks like it's simplified, but I'm going to expand this multiplication. So if I do y minus 4 times y minus 3, well, that was a bell from class. School just finished. Anyways, y minus 4 times y minus 3, I can use FOIL, which means first, outer, inner, last. So I'm going to multiply my first terms, y times y, that is y squared, y times negative 3, that is minus 3y, negative 4 times y is minus 4y, negative 4 times negative 3 is positive 12. And I'm going to combine the terms in the middle, which will give me negative 7y plus 12. So I'm going to write this as my denominator, and this is the expanded form. So y squared minus 7y plus 12. Well, I know that 1 over y minus 4 plus 1 over y minus 3 is all of this. So I'm going to rewrite my expression. I'm going to rewrite it as 1 over 2y minus 7 over y squared minus 7y plus 12. Now this is still not in the simplest form because there's a division still happening here. Well, we know that we cannot divide fractions I'm not sure if you remember this rule, but the rule says that if you have A over B dividing C over D, what you do is, in order to divide them, you do the reciprocal of your quotient. In this case, it will be C over D. So you have A over B times the reciprocal of C over D is D over C. And I'm going to do the same thing here. In fact, I'm going to rewrite it so you can see it. This is the same as 1 divided by 2y minus 7 over y squared minus 7y plus 12. Again, because we cannot divide fractions. I'm going to multiply by the reciprocal of my quotient. In this case is this rational expression. So it's 1 times, the reciprocal of this is y squared minus 7y plus 12 over 2y minus 7. Well, we know that 1 times anything is just that. So my final answer is this, y squared minus 7y plus 12 divided by 2y minus 7. And this is the simplest form of all of that. If you have any topic that you would like me to cover here in my channel, please comment below, and I'm more than happy to post a video about that topic.